So this is ELC 131, Circuit Analysis 1, and the topic is the derivation of our parallel resistance formulas. Now we have two formulas that allow us to calculate the total resistance of parallel resistors, the product over sum, which is valid for two resistors only, and the reciprocal formula, which is valid for or can be used with any number of resistors in parallel. And I wanted to take a moment to show the derivation of these two formulas so you wouldn't think I just made this stuff up. So by definition, total resistance is equal to V source over I source. And in a parallel circuit, I can substitute for I source IR1 plus IR2. And again, from Ohm's law, we know that IR1 equals V source divided by R1, and IR2 is V source divided by R2. Now, with this term in the bottom of the fraction, in order to combine these two, we have to have a common denominator. So I multiply this times R2 over R2. I multiply this times R1 over R1, yielding this expression. Now that each of the terms in the bottom of the fraction have a denominator of R1 and R2, I can combine these into one, and with R1 times R2 on the bottom of the fraction, I can multiply the top and the bottom of the fraction times R1 times R2. The R1 times R2 will cancel in the bottom or the denominator of the fraction, yet be in the top of the fraction. And you note with this expression that Vs is common to all terms, so Vs can cancel or will cancel from all these terms, leaving us with RT equals R1 times R2 divided by R1 plus R2. Now, the other formula we have, the reciprocal formula, really is based on the fact that in a parallel circuit, we cannot directly add resistances like we did in a series circuit. However, we can add conductances. So G total would equal G1 plus G2. And substituting in from our definition of conductance, where conductance is the reciprocal of resistance, we have that G total equals 1 over R1 plus 1 over R2. Now, since R total equals 1 over G total, I can substitute this in for G total. So R total equals 1 over R1 plus 1 over R2. And again, I could put any number of resistances here. G3, R3, R3, and it wouldn't matter because, again, with the reciprocal formula, I'm really finding the reciprocal of the sum of the reciprocals of the resistances. So this is ELC 131, Circuit Analysis 1, and we'll continue talking about parallel resistances. Now, whenever we have resistors or resistances connected in parallel, understand that the total resistance always has to be smaller than the smallest resistor. And this is because the source has to deliver more current than any one resistor requires. And I mention this so that you as a student, when you're doing circuit calculations, can perform somewhat of a sanity check to see if your calculated values make sense or whether you've made some error entering the values in your calculator. Now, we've got a rule, I call it the equal resistance rule, that states that the total resistance of parallel resistors, equal value parallel resistors, is always equal to the value of resistance divided by N, where N is the number of resistors connected in parallel. For example, we see a circuit here where we have R1 100 ohms connected in parallel with R2 100 ohms, and our rule says that the total resistance equals R divided by N, 100 ohms divided by 2. So our equivalent circuit, as seen by the voltage source Vs, would be one single resistor with a value of 50 ohms. Now, if we included a third resistor in parallel with a value of 100 ohms, the total resistance would be 33.3 ohms. Again, the total resistance is R divided by N. Now, when there's a large difference between the value of resistors connected in parallel, the total resistance will always approach the smallest resistor. However, it always has to be smaller than the smallest resistor. And we take, for example, this circuit where we have two resistors connected in parallel. R1 is 100 ohms and R2 is 1 kilo ohm. And if we do the calculations, we find that the total resistance, as seen by the source, is 90.9 ohms. So you can see the total resistance is approaching, getting close to the smaller resistor. However, it's always going to be smaller than that smaller resistor. Now, you'll note as we progress through this course that I always, or I try to when possible, make use of the product over sum formula to calculate parallel resistors instead of the reciprocal formula. And let me show you why. For example, if we have two resistors connected in parallel, 330 ohms and 680 ohms, then using the product over sum, our total would equal R1 times R2 over R1 plus R2, which would be 330 ohms times 680 ohms divided by 330 ohms plus 680 ohms. Now, what I do when analyzing this circuit is I just make some approximations and say that 330 is pretty close to 300. 680 is pretty close to 700. So if I change these numbers to 300 and 700, then I get in the top of the fraction 2.1 k ohms. And of course, 330 ohms plus 680 ohms is pretty close to 1 kilo ohm. So just by approximating these values, I end up with a approximate value of 210 ohms. Now, if we were to perform the calculations, 330 times 680 divided by 330 plus 680, we actually end up with 222 ohms. However, by coming up with an approximate value, a ballpark figure, I then can say that, well, this number makes sense, 222 ohms, and I did not make some error or blunder when I entered these values into the calculator. So as you gain more experience with our circuit analysis, I hope that you'll make approximations of what these values should be so that you can have a good idea whether they make sense or not.